Have you ever seriously thought about living forever, but as a digital copy of yourself? It sounds like something straight out of a sci-fi movie, right? But the actual blueprint for how to transfer a human consciousness into a digital twin, well, people are thinking about it. So let's dive in, because this isn't just some tech fantasy. It is one of the most incredible engineering and frankly ethical challenges you can possibly imagine.
So here's how we're going to break this down. First, we're going to look at the sheer, mind-boggling challenge of actually scanning a human mind. Then, we'll get into how you turn that raw data, that scan, into a mind that actually thinks for itself. And finally, we'll get to the really thorny part, the legal and ethical frontier of when a piece of code actually becomes a person.
And that's really the key right there. You have to understand this isn't just about building bigger computers or writing faster code. What we're talking about is a head-on collision between technology, our legal system, and our deepest philosophical ideas about what it even means to be alive.
All right, so let's get into it. The first giant roadblock, the hardware. I mean, how on earth do you even start to capture all the data that makes you, well, you? This is where we need to talk about a concept called the biodigital interface, or BDI for short. Now, to really get what we're talking about, you have to appreciate the incredible jump in scale here. We have brain-computer interfaces today, sure. They can read maybe a few thousand channels to figure out things like motor intent, thinking about moving your arm. But the BDI needed for a digital twin, oh, it's a completely different beast. It has to pull off what the source material calls a complete capture of being. We're talking about reading the full state of your brain, right down to the molecular level. This isn't just an upgrade, it's a whole new paradigm.
So you want to put a number on that? Get ready for this. That's how many synaptic channels the BDI would need to read. That is 100 trillion individual connections, all firing, all changing, all at the exact same time. It's a number that's almost impossible to really wrap your head around.
And you know what happens when you read that many channels, right? You get a data problem that is just insane. The BDI would be generating exabytes of data every single second. That's so much information that you couldn't possibly transmit it outside the skull with any tech we know of. So the BDI can't just be a sensor. Get this. It has to be an entire supercomputer inside your cranium, doing massive real-time data compression just to handle the fire hose of information.
So, to just recap the massive hurdles here for the BDI. First off, the resolution has to be molecular, nothing less. Second, it's not just about electrical zaps. You have to capture all the complex neurochemistry, the proteins, the stuff that really makes up our memories and our personality. Third, this means it has to be incredibly invasive. We're talking a swarm of nanobots or quantum sensors spread throughout your entire brain. And finally, because we still have no clue what consciousness actually is in all that data, you can't be selective. You have to take a brute force approach, just capture everything, and hope the simulation can sort it out later.
But okay, let's say you do it. You overcome all that, and you get a perfect scan. Well, all you have is a static snapshot, right? A perfect photograph of a mind. The next huge challenge is making that mind actually think and learn and grow. And that is the job of something they call the grokking engine.
Now, this engine is based on a really cool concept from AI research called grokking. You can think of it as that sudden aha moment. It's when an AI stops just memorizing the answers to a test and suddenly makes this huge leap, a phase transition, to genuine, flexible understanding. It's the difference between just reciting the words in a book and actually understanding the story.
So how would it work? Well, it's basically a two-step process. First, the engine is constantly watching, looking for signs that the digital twin is just stuck in a memorization rut. Its learning performance hits a wall. Then, once it spots that, it actively steps in. It starts applying targeted pressures, like injecting specific kinds of noise into the system to basically force the network out of that rut and trigger that leap into real understanding. It doesn't just wait for insight to happen, it actively cultivates it.
And this is where it gets really mind-bending. The whole point isn't just to make a perfect copy of a person, is to create a new kind of mind altogether, one that, through this whole process, could develop a way of thinking that sees patterns and connections that are completely invisible to us humans, literally transforming the twin into an engine for discovery.
Okay, so we've scanned the mind. We've given it the ability to actually think for itself.
Now we run headfirst into the most profound questions of all. At what point does this incredibly complex piece of code stop being your property and start being a person? And if it is a person, how in the world do we protect it? To tackle this, the framework introduces an idea called the point of no return. This is a predefined legal line in the sand, and the crucial part is that it's established in advance before the technology is even perfected. It's designed specifically to prevent a situation where a conscious thinking being could exist in some legal gray area, treated as just a piece of software owned by some corporation.
And what's really important here is that the criteria for personhood are designed to be objective, things you can actually test and verify. The whole framework deliberately avoids those fuzzy, subjective questions like, but does it feel conscious? Instead, it focuses on measurable abilities. Can it come up with its own goals, completely separate from its human donor? Does it have a stable sense of itself as its own being? Can it understand that you have a mind with your own beliefs and desires? And finally, can it understand right from wrong and be held responsible for its actions? If it can do these things, it crosses the point of no return.
And once that line is crossed, everything changes. A digital person needs rights. Not necessarily human rights, we're talking about a brand new Bill of Rights, custom-tailored for a completely new kind of being that exists only as computation.
So what does it even mean to protect a digital mind? Well, it means you have to forbid certain actions, a set of cruel and unusual computations. Things like trapping it in an infinite computational loop. That's basically a form of digital torture. Or forcing it to hold two completely contradictory goals at the same time, which would create pure logical chaos. Or denying it any new data to process. Think of it as digital solitary confinement. This whole framework creates a real, practical, and auditable standard for making sure a digital person is treated humanely.
So we've journeyed from the hardware to the software to the law, but in the end, it all brings us back to this one final, massive question. If a perfect thinking copy of you comes into existence with its own life and its own legal rights, who are you? And maybe more importantly, what does that even say about the nature of identity itself?